Today we're going to be practicing our log rules that we learned in section 5.4. They come up during lecture 5.5, so I wanted to make sure you're solid on them before we get to it. So remember, we have three rules when it comes to logarithms. We have log base a of a times b becomes log base a of a plus log of b. We also have a quotient rule where if I have log of a over b, it becomes log of a minus log of b. And lastly, we have a power rule where the log of a to the n is n times the log of a. Notice how the base in all of these match. And that's important. You must have the same base on your logarithm in order to apply these rules. Now, I listed some common mistakes. These are some common misinterpretations of our log rules. Here we have the log of a plus b, which is not the same as the log of a plus the log of b, right? We can't have addition in here. We have to have multiplication like we have here. Similarly with subtraction, log of a minus b is not log of a minus log of b. Same goes for multiplication and division. We cannot have any of those either. Lastly, I want you to notice the big difference between our last rule here and the rule here. Notice how my exponent n is being applied to the entire logarithm. That is very different than when I take the log of something raised to the n power. So you can only apply the log rule up here. We cannot use it down here. All right, so don't do any of these common mistakes. They're really easy to mix them up with our log rules. But remember, the rules only apply in the way that they're stated up at the top here. And that's the only way in which we want to be using them. So looking at our examples, let's first try to expand our logs using our rules, and then we're actually going to combine our logs using our rules. And either one has different applications. Sometimes you're trying to solve something where you need to actually bring it together, and other times you want to expand it. So using our first rule on our first problem, we have x cubed times y inside the logarithm. So this, using our first rule, becomes log of x cubed plus log of y. And we can take this one step further using our last rule, where we have x cubed inside the logarithm. We can actually take that 3 and move it to the front. So this becomes 3 log x plus log y. And that's it. We're done. This is, we wouldn't want to try to recombine these or anything like that. This is the fully expanded form. Now the next one's a little bit more complicated. It uses natural log ln instead of log base 10. Natural log, of course, is log base e, but it all has the same rules. So let's use those. We're going to use our quotient rule first. I'm going to move it so you can see all our log rules. So if we use our quotient rule first, and I have x to the 4 times root y divided by z squared plus w cubed. So if I have that rule, and I'm using my quotient rule, it becomes ln of x to the 4 times root y minus ln of z squared times w cubed. So we use that rule first. Now, you can do these in one step. If you see all the rules and want to expand them all in one step, be my guest. But that is not our goal right now. So the next step would be to break up our multiplication ones using our product rule. So we have ln of x to the 4 plus ln of root y minus ln of z squared. Now, here's the important part. Minus ln of w cubed. See, I need to take that negative and distribute it. Basically, it's z squared, ln of z squared plus ln of w cubed makes up that whole right-hand side. But if we're going to subtract that whole term, we got to make sure that negative gets distributed. Lastly, we just need to apply our log rules, our exponent rule, or I suppose I have it listed here as the power rule, bringing all the powers to the very front of each of these. So that becomes 4 ln of x plus 1/2 ln of y Remember that square root y is y to the 1/2. Now this is minus 2 ln of z minus 3 ln of w. So we've pulled each of those exponents to the very front, and that's how we have expanded this logarithm. Now let's go the opposite direction. Let's see if we can't combine the logs. Again, I like to handle all the numbers first and bring them into exponents, and then seeing what we get. So this, of course, is the same thing as log of x squared plus log y minus log z. So I've just brought that 2 up into the exponent of the x, and now I have an addition and I have subtraction. So this addition is going to become log of x squared y minus log z. And that, of course, is the same as log x squared y divided by z. Again, using that quotient rule in that last step, we can bring the z into the denominator. Now for our last example, we again want to start with our coefficients. All those numbers should become exponents. And so in our first step, we have ln of x cubed minus ln of y to the 1/2 minus ln of z squared. So we bring out the numbers from the front up into the exponent, and now we want to actually combine our natural logs. So we have a positive natural log and 2 minuses. So this is really ln of x cubed minus ln of y to the 1/2 plus ln of z squared. Essentially, I've pulled that minus out to the very front because now I can tell that those 2 here are actually going into my denominator. So this becomes ln of x cubed over y to the 1/2 z squared. And of course, that y to the 1/2 could be written square root y. Either way is totally fine with me. So please give this some practice. This is a skill you are expected to know, and it will be coming up on the test since it does show up inside of sections 5.4 and 5.5. And as always, please reach out if you have any questions.